Hello, welcome to Hawking College Lab 1102, Week 3, Day 2. We're going to jump right back in and continue our discussion of some vocabulary and concepts from analytical chemistry. So if you remember from Monday, we talked a bit about interference. So we're going to continue that and talk a bit today about how to compensate for interferences. The first way is to do a method blank or reagent blank. It's basically you are preparing a solution with no sample in it. So if your sample preparation procedure, you basically go through your sample preparation procedure without including the sample. So if it is to dissolve your sample in something, you and then boil most of it off and dilute that. You boil a chunk of your whatever you're dissolving it with off, and then dilute that. So when we did metals testing at the pulp mill I used to work at, we dissolved the pulp sample in nitric acid and then dilute that to usually 100 milliliters. So I would just dissolve, boil off some nitric acid and dilute the couple milliliters that were left to 100 milliliters, and that would be my method blank. Um, what that is telling me is how much of my reading might be due to the the my overall method or the included in the reagents that I'm using within that method. Another thing we do is calibration. You build a calibration curve. You get some standards. So a solution where you know what the concentration is in that solution. Um, they can be you can do this two ways. You can either make the standards yourself, in which case you have to be very exacting, or in a lot of cases you can purchase pre-made standards, and in which case somebody else had to be very exacting, and you just have to trust them, and so you get standards at multiple strengths, and you you take your measurement with those standards and you develop a curve that says this signal, whatever it is this strength based on these standards. I will sketch one of these out in class during the class time later. Um, Finally, let's talk about sampling. Um, there are a lot of things that you can do wrong in terms of a procedure and a method. A lot of possible ways to mess things up. Sampling is honestly one of the ones that can have the most impact. If you've taken a bad sample, um, whatever data you get out is quite likely worthless. So, if I'm sampling if I'm sampling river water and I pull my sample out of a puddle next to the river, that's not going to tell me anything about the river. Um, if if I need to measure biological activity in my sample and I wait 3 days with my sample in a warm room, I've destroyed any data in that sample as it's grown more stuff. So there are lots of possible ways to mess this up. I've seen this in the field. I I was interviewing for a job in Missoula, and one of my potential coworkers had sampled something. They thought it might be a biological contamination problem inside one of the tanks, and the chemical vendors' anti-mold, anti-biological agent didn't seem to be doing it, so they pulled a sample and sent it off to the lab to test. And they had to put it in the mail, and it was probably at least 2 days in transit. But they didn't do anything to preserve the sample while it was in transit. So it came in with, it was growing stuff. Um, and the vendor said, yeah, but the sample wasn't preserved at all, so of course it grew stuff in transit. So basically, they wasted the money to ship it, they wasted the money on the test, and it didn't tell them anything, because the data wasn't worth anything when it came in. So in terms of sampling, both in what you sample, where you sample, how you preserve the sample, all of that is very important and can have a huge impact on whether or not your data even means anything, as well as how accurate your data is. All right. Once you have developed a procedure, what you need to do is validate it. So you need to demonstrate that it's effective, demonstrate that it's repeatable, that if you run the same sample multiple times you get the same results, and demonstrate that it's repeatable elsewhere by someone else. So if I run this sample and get a result, if I send this to a lab across the country or across the world, they can run that sample using my method and get the same results. Okay, so let's talk a little bit about protocols. Protocols very typically include internal controls and audits. I know I haven't mentioned it before, but my wife used to be an analytical chemist. She wasn't one for as long as Fred was, so I'm sure he has much better and more stories. But we were discussing this recently, and I have a lot to learn about protocols and being exacting. It's become very clear to me that this is one of the weaker areas in my background, because for most of what I've done in the lab, this level of accuracy hasn't been necessary. For what my wife has done in the past, working in a public health lab and in an environmental lab and in places like that, it was very important. So internal controls and audits, it's basically built-in checks. So a lot of times with some of the instrumentation, you can set it up in, the samples are in vials, and it pulls from this vial, does the test, automatically moves to the next vial, does the test. So you will start off with a blank. Then it usually will do either a full calibration curve or possibly just 1 or 2 points so you can check the calibration. Then there'll be a few samples, and then it will do the blank and calibration check again, so that if those don't come back okay, you throw out everything in between the blank and calibration check and fix your instrument so it's reading right, and then start again. And you do it every few samples so you don't lose as much. If samples 1 through 8 have good blank and calibration checks on either side, that data is good. You can move on and use it. If then 9 through 16 you've got a bad calibration check at the other end of that, that's 8 samples you throw out, but it's not all 16. It's just that 8. Another thing that some of these commonly include is duplicate or split samples. So usually it's you have the same sample in 2 small vials, or you've got basically two samples from 2 identical samples, be a duplicate. The last one is spikes. this is the one that I realized just this morning that I had not understood completely. Um, there are apparently two types of spikes. One is what you use when you are not expecting to see anything in your testing. So for nitrate and nitrite testing in drinking water, there should be no nitrates and nitrites in the water. You're not expecting to see anything. So every so often you have a sample where it includes a spike of nitrate or nitrite that should hit roughly halfway through the range. Um, you, you you have basically a calibration type sample you've prepared to have that much, so that you can see that your instrument is hitting in that range, and double check that it's working, and that you're not seeing something in the other samples because there's nothing there, not that you're not seeing something because something's gone wrong. Um, the other type of spikes, and it's the one the textbook discusses, is uh, adding a bit of extra analyte to a sample so you can help check for interference, or yeah, so you can help check for interference. Um, you need to be careful with doing that, because if you get too much in, then it might not pass all the way through your instrument before the next sample goes through, and you've just messed up every sample after it. So that type is usually run at the very end of a group of samples. Is the last one you do. And Fred will probably next semester in instrumentation have more to say about this, and he will have had more experience than I have in running tests this way. As I said, in my background, this level of precision was not necessary for my work, so I don't have the experience in that level of precision. In a testing lab, a commercial testing lab, it is going to be that important. In an internal industrial lab, depending on where in the process you are, it may or may not be that important. So if you're doing the final checks on the product going out the door, it will be that important. For some of the ones in during the process, depending on the accuracy level you're after, on the not accuracy level, on the detection range you're working in, it may or may not be as important. The more the generally the smaller the concentration, the harder it is to measure something. So the easier it is to mess things up. So the more important including internal checks becomes. Okay, let's talk a little bit about overall methodology. And section 3.7 in the textbook has a great story about this, and I encourage you to read it, because I think it's likely to be at least somewhat applicable in the cannabis industry in the near future. Essentially, there was a contaminated site that needed to be cleaned up, and going off memory here because I did not just reread this. And so they were coming up with testing methods to monitor the cleanup. And at the time, they did not have established methods for what they were doing. So they adapted a method from another field and ran with that to start with. And what they learned was that it was not measuring what they needed to be measuring to monitor their cleanup well. So they had to start adapting those methods. So I suspect that we're probably going to be seeing similar trends in these initial phases of the cannabis industry, where we're using cannabinoids in a different way than in the past. We're not after, you know, has this person been smoking marijuana? Yes, no. Um, you know, it's not a pre-employment urine screening test. It's now a how much THC is in this edible type of thing. So it's still testing for the same compounds maybe, but for a different purpose. So the methodology needs to change. So that's what I'd like to use for the discussion today. Is, you know, spend some time thinking about what you know about cannabis testing and the methods they currently use, um, and where those methods might have come from and how they might need to be adapted. I have to admit I don't know a lot about the cannabis testing industry at present myself, and I believe that you all probably know a bit more about it than I do. Um, if not, feel free to speculate on where they might be going for the initial test methods that then might be adapted. Okay, that's all I have today. It should be a fairly short lecture, and during the course time we will spend more time working on sample problems, and I hope to see you all then. Thank you.